So we're going to continue with the chain rule. We've already talked about the function notation version. We've used the function notation version to take the derivative of two compositions with three functions. And now we're going to talk about the Leibniz notation, or the variable notation. So one moment while I get my screen ready for that. Sorry, my thing is just going really slow. There we go. Okay, so I guess one of the reasons you should be aware of the fact that there are these different notations are because calculus was independently discovered by Sir Isaac Newton and Gottfried Wilhelm Leibniz. Newton liked to use basically something akin to the function notation that we use today, whereas Leibniz came up with his own notation. His notation is inspired by the fact that the slope of a line is the change in y over change in x, which then is why we call the derivative dy over dx, because the derivative is basically the slope of a tangent line. Okay. So the Leibniz notation looks more like a fraction, basically, I guess you could say. So I'm going to show you how we're going to go from the function notation to the Leibniz notation. So remember, for the function notation, we're taking the derivative of f of g of x. And that tells us that it's equal to f prime of g of x times g prime. Okay, so what we're going to do is we're going to say that y is a function of u. So this function f over here, instead of calling it the function f, we're gonna, so I guess actually let me say this. The function f has as its independent variable u. So you input a u variable, and then the output or dependent variable is y. Okay. So this function f, it inputs a u variable, outputs a y variable. Now notice that f has something composed into it, g. So my function g will have x as its independent variable, but it's going to have u as its dependent variable. So notice the roles have changed here. In the line above, u was independent, whereas here u is dependent. And x is the independent variable. Oh my god, I cannot spell. Okay, wait, I screwed up. Independent. Okay, so now we're going to rewrite f of g of x. Now, g of x can be replaced with u. So that's f of u. Now, what is f of u equal to? Y. So y is equal to f of g of x. So I guess I should point this out. Y has u as its independent variable. And this is basically the problem here. So there's a mismatch. You can't take the derivative of y with respect to x because u is its independent variable. taking the derivative of y with respect to x makes no sense because the independent variable of y is u and not x. So if you want to take dy dx, that's the derivative of y with respect to x, what I'm saying here is that that should make no sense to you because we said earlier that the independent variable of y is u. Okay? So taking the derivative of y with respect to x is the same thing as taking the derivative with respect to x of f of g of x. Okay? Now, we know that the derivative of f of g of x is f prime g of x times g prime x. So there's two things here. Okay, now the cool thing is that you can like make replacements. You can actually figure out what this g prime of x is going to be by looking at this stuff over here. You can take the derivative of x with respect to u, and that is g prime x. So this is going to be du dx. Likewise, you can figure out what f prime of g of x should be, because f prime of g of x is the same thing as the f prime of u. And because f has its independent variable as u, that's equal to df du, which is actually the same thing as dy du. So that one in red, that boxed red turns into dy dx, sorry, dy du, my bad. The green box becomes, let's put it in green so they match. What is it? I had du dx. So what we have just found out is that the derivative of y with respect to x is equal to the derivative of y with respect to u times the derivative of u with respect to x. And if you look at this as a fraction, why does it make sense that the left-hand side fraction equals the product of the two on the right? Like, what do you notice cancels, basically? Yeah, the du's. And this is actually why Leibniz liked this notation. Okay, this is weird. Y has u as its independent variable, so like what I said up here, it doesn't make sense to take the derivative of y with respect to x, because x is not the independent variable of y the way we've defined it. The independent variable of y is u, which is why it makes sense to take the derivative of y with respect to u. Then, how do you make it in terms of x? You take the derivative of u with respect to x. Okay. So let me show you like an example how this works. Let's say that you want to take the derivative let's say that your y is equal to x over 3x plus 2 to the 5th. Okay, what you want to do is rewrite this in terms of u. So I'm going to call this stuff in here u. U is going to be x over 3x plus 2. So now I can rewrite this. I can say y equals u to the 5th. Okay, do you see how if I call u x over 3x plus 2, then that x over 3x plus 2 just becomes u to the 5th. Okay, and then I use the chain rule. This says that the derivative of y with respect to x equals the derivative of y with respect to u times the derivative of u with respect to x. So you look at this part right here. That's what I use to calculate dy du. If y is equal to u to the fifth, the derivative of that with respect to u is 5u to the fourth. Okay, and now I use this part here to calculate du dx. If u equals x over 3x plus 2, I can now calculate the derivative of u with respect to x. I'm going to use the quotient rule. Okay, see you, person who told me they're leaving. You take the derivative of the top, the derivative of x times 3x plus 2, minus x times the derivative of 3x plus 2, all over the bottom squared, which will be, the derivative of x is 1, so you'll get 3x plus 2 minus x times, the derivative of 3x plus 2 is 3. So that's going to be 3x minus 3x, you're just going to get a 2 on top, so you're going to get 2 over 3x plus 2 quantity squared. That's my du dx. So that's going to end up right here, times 2 over 3x plus 2 quantity squared. Okay, now all of this is supposed to be in terms of x, so what do I replace my 5u to the fourth with? What do I need to put back into the u, basically? My u was x over 3x plus 2, so that's why you get that replacement, and then it's raised to the fourth power times 2 over 3x plus 2 quantity squared. This is my derivative of y with respect to x.